I want to talk to you today about the equation you see on your screen now. We have hydrogen gas, which does exist diatomically, and oxygen gas, which also exists diatomically. Now, the idea is these two can come together, and when they come together, it could rearrange to produce water. But when that happens, it's not like you leave behind one random oxygen atom that gets to go around and create a mucus everywhere it goes. Instead, it's going to create and it's going to combine according to a balanced chemical reaction. And so what the balanced chemical reaction is it says that if you start out with 2 oxygens and 2 hydrogens, how many of them do you need to make a certain number of the product? So let's see how we want to do this. Let's say, since we had an extra leftover oxygen, we're probably going to need a little bit more of our hydrogens as opposed to our oxygens. So now, what if we do this? Because before we had made one pretty little water molecule, which looks a lot like this. And if we had 1 extra oxygen, we probably needed another set of hydrogen in order to balance it out. So now I have 2 water molecules that have been made. But what did they get created from? They got created from 1 molecule of oxygen and 2 molecules of hydrogen. That's how I created it, was I took apart my oxygens and my hydrogens and reformed them into my 2 waters. And so if we do it like this, we now put coefficients in front of our chemical formulas in order to indicate that we have 2 hydrogen molecules plus 1 oxygen molecule to yield 2 water molecules. And if we count both sides of the arrow, we should notice that it's balanced. What do I mean by that? It means, do I have the same number of red balls on this side of the arrow as I do on this side? Absolutely. I got 2 oxygens on both sides of my reaction. Do I have the same number of white ones on both sides? I do. I have 4 white hydrogen balls here and 4 white hydrogen balls on this side. And so in this case, it's balanced. And so when we're talking about balancing chemical reactions, think of it as, and I actually wanted to record my children this weekend, but it didn't happen. But the idea is with children, everything has to be fair. Fair, is it fair? And so I was going to have one kid be this arm and one kid be this arm, but it just didn't happen. But picture children fighting. If it's not fair, your reaction's not balanced. They each need to have the same amount. And so by that I mean the reactants, the number of atoms of each type and number should equal the number of atoms and types on the product side. So reactant atoms should equal your product atoms. And if you do that, there's a whole system. So we're going to practice this, but you can practice it and get really good at just saying, how do I do that? And so what you do is you line up all the atoms in the middle, and then you say, how many do I need on both sides? And so we're going to practice that in following videos.